In the last video, we learned about Hess's law, the first part. What was the first part? Basically, it is about calculation of the enthalpy of the reaction based on the other equations with the known reaction enthalpy. Okay, that means we can manipulate with other chemical equations. We can multiply that by a constant. We can flip it over, and then the delta H for the reaction we have to multiply by -1. And we can also add up different reaction equations in order to get whatever we want. And we have to be careful on the calculation of delta H. Okay, so what about today? In this video, you are going to learn about the second part of Hess's law. We can use the second part of Hess's law to determine the enthalpy change of any reaction if the corresponding enthalpies of formation of the reactants and the products are available. That means we can calculate the enthalpy of the reaction based on the published data, based on the formation of each reactant and products. Mathematically, how do we write that? The delta H of a reaction is equal to the sum of each of the delta H formation enthalpy or enthalpy of formation of the product, the sum of that, minus the sum of the enthalpy of formation of the reactants. Okay, it looks complicated. Actually, it is not that complicated. But at least what we need is, we need to find each of these from a chart. It must be published. Okay, that means the second part of the Hess's law, we only need one chemical reaction. We do not need to manipulate with other chemical reactions. Okay, let's work on some examples. All right, let's look at over here. I'm working on number 18 now. Given the data in the table below, okay, so these are given. What is given? Each of the reactant and each of the product. The enthalpy of formation is given. So what is the question asked? We need to calculate the enthalpy of the reaction, the heat of the reaction of this chemical reaction based on the enthalpy of formation of each reactant and products, based on whatever we can find out from the literature or from this table here. Okay, let me rewrite what the mathematical formula is. It says delta H of the reaction. Sometimes we use RXN to represent reaction. Delta H of the reaction is equal to the sum of delta H formation of the product minus the sum of the formation enthalpy or enthalpy of formation of the reactant. Okay, well, too much math here. Let's do it one by one. How do I get the sum of the enthalpy of formation of the product? Let's look at this. Okay, so if I want to get the delta H of the reaction, so I would say delta H of the reaction will be equal to, all right, so let me write down the sum of the formation enthalpy of the product. And that will be over here. So let's look at, don't be confused. They both start with Ca, calcium. Okay, this one it is -2346. Okay, from this part. I can't even pronounce this polyatomic anion. All right, excuse me for that. All right, so this part. And what's next? Plus the enthalpy of formation of water. And that is over here. Be careful here, because you see the coefficient of 2 and therefore you have to multiply by 2. Okay, so for water is negative 285.9. Okay, so that is the sum of the enthalpy of formation of the product. And I need to minus the sum of the enthalpy of formation of the reactant. All right, let's do that. So I minus of the reactant, what do we have? Okay, calcium hydroxide. So I have negative 986.6. Okay, the next one, there's a coefficient 2 over here. Okay, the sum, so it must be a plus sign. Be very careful. You have to put a bracket here, or you have to put the parentheses here. Okay, otherwise you have to put a minus sign here then. Okay, plus 2 times, so let's look for this one. It's over here, negative 900.4. Okay, so let's see what that is. What I have is negative 2346 plus 2 times negative 285.9, and then minus parentheses negative 986.6 plus 2 times negative 900.4. Okay, let's see what I got. I got negative 130.4, and the unit will be kilojoule. Do I get anything? Aha, I find it here. All right, so the answer is negative 130.4. Okay, let's look at another sample. Let's work on another problem. Number 19. Given the data in the table below, delta H for the reaction will be equal to what? Okay, let's use Hess's law, the second part. That means delta H for the reaction is equal to, let me write it down, delta H for the reaction will be equal to the sum of the formation enthalpy or enthalpy of formation of the products minus the sum of enthalpy of formation of the reactants. Okay, let's plug that in. Over here, NOG, gas. Okay, let's see which one. See, I have NO, I have NO2. Make sure that you pick the right one. At the same time, you have to pay attention at the coefficient. There's a 4. Okay, so it will be equal to 4 times NO gas, so this is 90. It's not the 34 here, okay? It is the 90, be careful. All right, plus 6 over here times enthalpy of formation of water liquid, it is negative 286. Okay, so I get everything on the product side. All right, and then that minus the sum of the enthalpy of formation of the reactant. Over here, I see the 4. Okay, so 4 over here, ammonium NH3 is over here, so negative 46. Over here, negative 46 plus over here. Can I find oxygen over here? I cannot find oxygen. What happened here? All right. Remember over here, what is the enthalpy of formation for the ingredients that is in its elemental state? Anything that is in its elemental state and most stable state, it will be equal to 0. Okay, so be very careful. When anything, either product or reactant, when it's in elemental state and the most stable state, then the heat of formation will be equal to 0. Okay, so over here we get 0, so it's 5 times 0 over here. All right, I'm going to put everything in my calculator. So 4 times 90 plus 6 times negative 286, that minus parentheses 4 times negative 46 plus 0. So what I get is negative 1172. Okay, do I get any answer? Okay, here you go. All right.